All right, today we're diving into something that's working on your computer every single second, but you probably never seen it. Special identity groups. Think of them as the invisible gatekeepers of your digital world. They're automatic, and they are constantly deciding what you can and can't do.
I mean, really think about it. How is it that when you log in and try to open a file, your computer just knows? How does it know you're allowed to open one thing, but maybe not another? It's not magic, not at all. It's actually a really clever system working completely behind the scenes.
So here's what we're going to cover. First, we'll talk about what these invisible gatekeepers actually are. Then, we'll get into the rules of the game, how they operate. We'll meet a few of the key players you deal with every day, understand the security blueprint they create, and wrap up by looking at this idea of your digital shadow.
Okay, so let's get right into it. The invisible gatekeepers. What is this automatic system that Windows is using to control pretty much everything?
A special identity group is, well, it's a security group, but with a massive twist. No one, not even your system admin, can manually add you to it. Instead, the operating system itself just assigns you to the group automatically, based entirely on context. You know, things like how you're logged in or where you're connecting from.
Probably the best way to wrap your head around this is to think of them as digital access passes. The second you sit down at your desk and log in, boom, your computer hands you an interactive user pass. If you connect from home over the network, instantaneously you get a network user pass. You never have to ask for them, they just pop into existence exactly when they're needed.
And that right there is the key difference. A regular group is like a fixed guest list for a club. An administrator has to physically put your name on the list. But a special group, that's more like a temporary access pass that just materializes when you walk up to the door, lets you in, and then vanishes. It's totally fluid, totally automatic.
So how do these automatic passes even work? What makes them tick? Well, that brings us to the rules of the game, the three core principles that make this whole system possible.
It really boils down to three golden rules. First, they're automatic. The system assigns you one the moment you sign in, no questions asked. Second, they're dynamic. The interactive user right now might be you, but an hour from now on that same machine, it could be your coworker. The group just represents whoever is there at that moment. And third, they are completely unmodifiable. An admin can't just open up a list and add or remove people because there is no static list. The operating system is the only one pulling the strings here.
All right, so we know the rules. Now let's meet some of the key players. These are the digital access passes that your computer is handing out all the time, whether you know it or not. And we have to start with a really fundamental concept in Windows security, and that's the difference between the Everyone group and the Authenticated Users group. Getting this distinction right is absolutely critical. The Everyone group is, well, just like it sounds. It's incredibly broad. It includes pretty much any user that has some kind of access. But authenticated users, now that's much tighter. It only includes users who have successfully signed in with a real username and password. In other words, their identity has been proven. And that is the crucial point. This is why, if you have a sensitive folder, you give access to authenticated users, not everyone. By doing that, you're guaranteeing that anyone who can even see that folder has a verified account on your system. It closes a massive potential security loophole.
But hey, access isn't just about who you are, it's also about where you're coming from. And this brings us to another great comparison, the interactive group versus the network group. This is such a simple but brilliant security feature. Look, if you are physically sitting at a computer, keyboard in hand, and you log in, you are part of the interactive group. But if you're on your laptop across the building and you access that same computer's files over the network, you're now in the network group. This lets the system set up different rules based on whether you're there in person or connecting remotely. Okay, so we've met the players. We know the rules. But so what? Why does any of this actually matter? Well, this is the security blueprint. This is the real-world payoff. You know, Microsoft's own documentation says it perfectly. This is all about efficiency. It's a powerful way to assign access to resources across a huge network without forcing an admin to manually manage permissions for every single user for every single file.
So the payoff here is huge, right? It makes managing permissions so much simpler, especially at a large scale. It automatically enforces security rules. And what that means is it protects sensitive files by making sure that access is always granted based on the right context. It's just a smarter, way more dynamic way to handle security.
And all of this leads us to one final kind of cool idea.
this concept of your digital shadow and what it could mean for the future of our online identities.
Think about it. Every single thing you do, logging in at the office, connecting from a coffee shop, even an automated task that runs in the middle of the night, is assigning you one of these temporary, invisible identities. It's like you have a digital shadow that follows you around, constantly changing its shape to give you the exact permissions you need for that specific moment. And just as importantly, nothing more.
Which leaves us with a big question to think about. As our digital lives get more and more complex, and we connect from more devices and more random places than ever before, how are these invisible identities going to have to evolve? How will our digital shadows get even smarter to protect us in a world where the line between a safe network and an unsafe one is basically gone?